Okay, so we are looking at quartic equations which have the highest power of 4. And what we are doing to solve them is we are substituting y for x squared. So instead of x to the 4th, we'd have y squared. Instead of 16x squared, we'll have 16y plus 64 equals 0. So we make the substitution that allows us to put it into the quadratic formula. So let's do that. Negative 16 plus or minus square root of 16 squared minus 4 times 1 times 64 all over 2 times 1. So if you do the math in here, what actually happens is we'll get negative 16 plus or minus the square root of 0, which is interesting, over 2. So that's different than what we had on number 1. So if I add 0 or subtract 0, I'm basically going to get the same answer. So I'm basically just have 16 over 2 for both of those, which is negative 8. So that means that y equals negative 8. But remember that y is actually x squared, and what we're actually trying to solve for is x. So we're going to put the x squared back in and then solve that. So if we square root both sides, we have to do plus or minus the square root of negative 8. And we're going to have some i's here since we have a negative under the radical, but we also need to birthday cake the radical. So 8 could divide by 2 to get 4, divide by 2 you get 2, divide by 2 you get 1. So basically we just did the prime factorial. It's 2 times 2 times 2. I can take a couple of those to make 2 squared, which means this is plus or minus 2 radical 2. And remembering that this is negative, I have to put the I in there. Now, technically, we added 0 and did this, and then subtracted 0 to get this. And so there's this thing, if you only get one answer up here, they would say that this root has a multiplicity of 2. Basically, that just means that we got the same answer twice. In theory, we did this once with plus 0 and then did it again with minus 0. Anytime that 0 shows up in there, your answer has a multiplicity of 2, which is not a huge deal for things like your ACTs, SATs, that sort of thing you're preparing for, but it will show up in a college algebra class. What? It will. So that's something to just note. Anytime you get the plus 0 and minus 0, technically that means the same answer happens twice. And so since the same answers happen twice, which means that the positive 2i squared root of 2 is there twice and the negative 2i squared root of 2 is there twice. It's not a huge deal, but it's one of those things that sometimes stumps people when they're taking college algebra, and then they come ask me later, oh, the lights are off. That's why this isn't.
It keeps going from orange to blue.
It's because the light from outside is changing. All right, so I'll turn the lamp on here and we'll do the next one. So on the next one, we are again going to let y equals x squared. If you don't like y, you can use whatever letter you want. So we'll have 3y squared plus 14y plus 8 equals 0. And then now we've changed it into a quadratic, and we can use the quadratic formula. So negative 14 plus or minus square root of 14 squared minus 4 times 3 times 8 all over 2 times 3. So just putting it into the quadratic formula. If you do the math underneath the radical, you will get negative 14 plus or minus the square root of 100. And then 2 times 3 is 6. And that is going to be 10. So we'll have negative 14 plus or minus 10 over 6. So we go ahead and do the adding and the subtracting. So negative 14 plus 10 is negative 4 over 6, which would be negative 2/3. And then if we do negative 14 minus 10, that's negative 24 over 6, which gives us negative 4. So if this equation, the quadratic, was the only one we were trying to solve, that would be our 2 answers. But this is what y equals. So we need to remember that y is x squared. That's what we did in the beginning. And so x squared equals negative 2/3. and x squared equals negative 4. So let's look at the negative 2/3 first. This one's kind of interesting. So we're going to square root both sides. And we have to put a plus or minus when we solve equations that way. And we know there's going to be an I there because of this. We have to think of this as plus or minus the square root of negative, we're going to break it apart. The square root of negative 2 over the square root of 3. And so do you guys remember the rule where you can't leave the radical in the denominator? So you've got to multiply by the square root of 3. And so this would be plus or minus the square root of negative 6 over 3. And then for this, 6 is just 2 times 3. It's not very interesting. If you try to simplify that, you'll just end up with plus or minus I square root of 6 over 3. The only thing we can really take out is the negative and put that on our answer. So fractions are a little interesting if you run into those negatives. The other answer that we had was negative 4, so we would have x squared equals negative 4. We'll square root both sides, and when we do this side, we do a plus or minus. And so it'd be plus or minus 2i, because the square root of 4 is just 2. And so we get 2 answers here and 2 answers here, and they happened to all be imaginary numbers. So if we were to look at the graph of this quartic, sometimes they're kind of W-shaped, and sometimes they're more like a skinny parabola. It just depends on what all the coefficients are on everything. But it means that it doesn't cross the x-axis at all. So these are all complex or imaginary answers, whatever you want to call them. Okay, let's do number 4. So we start by reminding ourselves that we're going to replace x squared with y, which means replacing x to the 4th with x squared. It just takes all the powers and basically divides them in half so that we can use the quadratic formula. So put it into the quadratic formula. If b is negative and I have negative b, then I have to use positive 21. Plus or minus negative 21 squared minus 4 times 2 times 40 all over 2 times 2. So if you do the math underneath the radical, you will have the square root of 121. So that happens to be 11. So 21 plus or minus 11 over 4. I think, if I remember correctly, last year I made this so that a lot of these did come out whole numbers here, just to make the rest of this a little easier. So if I add 21 and 11 together, I get 32, which divided by 4 would just be 8. So y would equal 8 for the first part. And 21 minus 11 is 10 over 4, which reduces to 5 halves, or you can make it 2.5 if you want. I'm going to just leave it 5 halves. So remember that these are not your final answers. That's the biggest mistake people make, is they get through all of this and they think they're done. Because normally with quadratic formula you would be. But remember, we're trying to solve for x, not the y that we substituted. So then we have to remember that x squared equals 8. And so if I square root both sides there, do a plus or minus square root of 8. And I feel like we have simplified 8 enough times I can just tell you it's 2 radical 2. We did it earlier. We did it in the problem right above on number 2. So I'm just going to skip to that. And then I also have 5 halves. So x squared equals 5 halves. This is another fraction one. So when we square root, remember to do the plus or minus, and it's like square root of 5 over square root of 2. So what would I need to do with that? Multiply by the radical 2. So get plus or minus radical 10 over 2. And since that was positive, we don't need any i's. I should put x equals next to that. And those are our 4 solutions. And that one had all real solutions.